Is it worth it to add an isolation transformer? Douglas in Green Bay, Wisconsin. I think that's a famous football place, although I'm not much into sports. Hey, Paul, what are your thoughts about isolation transformers for the 120 volt AC feed to my amp? Is it worth the investment? No, I don't think so. And I'll tell you why. Let me explain to you first what an isolation transformer is. Because I think we all know that our power amplifiers have input transformers, and by input I mean to the power supply. They have power transformers. Everything in your system has a transformer to isolate it from the 110 volts or the 230 volts that's coming in, right? So we all have that. An isolation transformer is another step to isolate your equipment from the line. And they seem to be very popular amongst a group of people. I know several studios that we have looked at and talked with the owners have used isolation transformers to try and isolate the entire studio from the AC line. And asked why they do that, they basically said, well, we just need cleaner power. And I guess it does give them some measure of isolation and cleanliness. And to be specific, an isolation transformer is just, well, it could be any size, but generally it's a fairly big device. And as we know, transformers are what? Coils of wire and a lot of steel. So any transformer, regardless of its purpose, has two coils of wire, the input, which is called the primary, and the output, which is called the secondary. Now these are just coils, big wraps of wire. And in the primary side, when we energize that, it creates a magnetic field that goes up and down with the signal. Well, let's just use a power example here. So 60 times a second or 50, the power is going to plus, to minus, to plus, to minus. And as it does that, the magnetic field grows and collapses, grows and collapses. And when that happens, the second coil, the secondary, the one that's very close, generates electric energy in response to the moving magnetic field. This was something that was found by Faraday long, hundreds and hundreds of years ago. If you move a magnet near a coil of wire, you will induce electric energy. And if you have a coil of wire with energy into it, you'll induce a magnetic field, right? The two are intertwined. So an isolation transformer is simply a one-to-one transformer where the input and the output coils are identical, and there's a lot of separation between the two so that we get as much rejection of noise and things on the line that are possible. Now, why do I object to it? Well, first off, we all already have isolation within our power transformer inside of our equipment. It's not as much isolation as a good, well-designed isolation transformer. Granted, I mean, properly designed, a good isolation transformer can have many dB of isolation, but I don't find that that is the biggest problem in power, which is why we make AC regenerators. The biggest problem in power is impedance, regulation, and sine wave shape. And I've gone over this a number of times. I'll try and do it again on the blackboard and try and on the whiteboard and try and show you how a clipped sine wave at the top, right at the peak where you need energy, that is missing often in our systems. And when that's missing, your system is robbed of electrical energy right when it needs it. And as your system draws energy, it's drawing down the line voltage because of the resistance inside of the wire, because of any number of factors that play into the delivery of energy to our systems. And the last thing you want to do is place something else in series with the line. And an isolation transformer is absolutely in series. And it's only going to make that impedance problem worse. Don't want to make it worse, want to make it better. So either don't do that or put an active AC regenerator, which can give you 10 to 20 times lower impedance, regulate the power, and fix the problem right as it should be. And that's what you ought to do. Okay? Thanks.